Welcome to the Worldwide Center of Mathematics Pre-Calculus Practice Problems playlist. For the full problem and solution transcript for this problem, you can see the link in the description of this video on our YouTube channel. So this particular problem asks you to solve the following system of equations using Gauss-Jordan elimination. So the way that we're going to do that is we're going to set up an augmented coefficient matrix, and then we're going to use elementary row operations to put it in reduced row echelon form. Okay, so what I'm going to do here now is I'm just going to make this system of equations into an augmented matrix. So I'm just taking the coefficients off of all the variables, and then I'm going to augment it with the constants on the right-hand side. So here we have 1 from the x, 2 from the y, 0, z, and then just going to augment it here. And then we have 2 as the constant on the right-hand side. 1, 3, 4, doing the same thing with the second equation, is going to be equal to 2. And then we have 1, x, no y's, and 2 z's, and we have a constant of 1. Okay, so now we need to use elementary row operations to put this matrix into reduced row echelon form. So it looks like a good first step for us is going to be to eliminate all of the x's to get the leading one in this upper left-hand corner here for the x's. So it looks like a pretty easy way to do that is going to be to subtract the first row from the second row and replace, do the same thing for the third row. So here we're going to replace row 2 with row 2 minus row 1. And down here for the third row, I'm going to replace row 3 with row 3 minus row 1. Okay, great. So row 1 just stays the same, so I'm just going to copy everything over. So we have 1, 2, 0, 2, and then row 2 minus row 1, so 1 minus 1 is 0. 3 minus 2 is 1. And 4 minus 0 is going to be 4. And finally, we have 2 minus 2 is going to be 0. And we're going to do the same thing with the third row. So row 3 minus row 1. So 1 minus 1, 0. 0 minus 2, negative 2. 2 minus 0 is 2. And 1 minus 2 is going to be negative 1. Okay, so now it looks like we're going to try to eliminate, we've eliminated all of the x's and we have a leading one here. We're going to try to get this to be a leading one by getting a 0 here. So we're going to do that by replacing the third row with row 3 plus 2 times row 2 in order to get this to be equal to 0 here. Okay, so the first row stays the same. Just copy that down. 1, 2, 0, 2. Second row also stays the same. 0, 1, 4, 0. And 0 here in the second row, in the third row, excuse me. So 2 times row 2 is going to give us here 2, I'll just write this down here, so 2, 8, and 0. So we're just going to add these things together here. So we have 2 plus negative 2 is going to be 0. 8 plus 2 is going to be 10. See here, 8 plus 2 is 10, and then 0 plus negative 1 is going to be negative 1. Okay, great. So now here we're going to divide everything. Just erase this. Okay, so here, in order to get a leading one here in the bottom row, we are going to divide the entire bottom row by 10. So times 1 over 10 in order to get this to be a 1 here. Okay, so that leaves us with the first two rows stay entirely the same. So we have 1, 2, 0, 2, 0, 1, 4, 0, and 0, 0, 1, negative 1/10. Okay, great. So now we have row echelon form. We need reduced row echelon form. So in order to do that, we're essentially going to do back substitution within our matrix. So first of all, I'm going to eliminate the 4 here by doing replacing row 2 with row 2 minus 4 times row 3. And we've already cleared this out of this column here, so looks like we're fine. We don't need to do anything for the first row yet. So first row stays the same. 1, 2, 0, 2, 0, 1. The 1 will stay the same, and 4, so negative 4, I'll write down here. We have negative 4 times this is negative 4, and negative 4 times 1/10 is going to be 2/5. Okay, so now we're going to add, so 4 plus negative 4 is going to be 0. And 0 plus minus 4, okay, right. And so 0 plus 2/5 is going to be 2/5. So we're left with 2/5 here. Then we have in the bottom row just stays the same, 0, 0, 1, negative 1/10. Okay, so it looks like we're almost done here. We just need to do one more row here, the first row. So we need to take care of this 2 here. So we're going to replace row 1 with row 1. Row 1 minus 2 times row 2. Okay, so that is going to give us here. So the 1 will stay the same because we have a 0 here. So we have 1 here. So minus 2 times row 2 is going to be negative 2, 0, and negative 4/5. Right? Yeah, negative 4/5. Great. Okay, so 1, 0. So 2 minus 2 is going to be 0. 0 minus 0 is going to be 0. 0 plus 0, I should say, is 0. We augment it over here with 2 minus 4/5 is going to give us 6/5. And now we just need to recopy the second and third row, and we're all done. So we have 0, 0, 1. 0, 1, 0. So you can see we have the identity matrix, which means we have reduced row echelon form here. 2/5, and then 0, 0, 1, negative 1/10. Okay, so now just for completeness' sake, we have it in reduced row echelon form, but we can write our solution as a matrix in and of itself. So we know our matrix, our solution x, y, and z can be written as, or here rather I'm using this notation just for consistency. It's the same thing. Is equal to, and we just copy down the right-hand side of our matrix here, 6/5, 2/5, and negative 1/10. And we're done. We've just solved the problem by Gauss-Jordan elimination, putting the matrix here into reduced row echelon form, and then we have our solution here. So for more of these pre-calculus practice problems, you can click on our playlist here. To subscribe to us, you can click here. And for centerofmath.org, you can click here. Thank you for watching.